Hi everyone. In this video, I am going to discuss about the laws in the first unit DC circuit analysis, where there are two laws in this unit. Let me explain about the first law, Ohm's law. Ohm's law, it states that at constant temperature, the current flowing through a conductor will be directly proportional to the applied voltage across the two ends of the conductor, where here a conductor is represented as an A, B and then resistor combined one combination, where A and B are two ends, where current is represented as I, the applied voltage is represented as V, where Ohm's law states that the current flowing through these conductors is directly proportional to the applied voltage of the conductor. It is represented as V is directly proportional to I, where V is equal to IR. R is the resistance of the limitations of Ohm's law. Ohm's law is not applicable to non-linear devices such as diode, voltage regulator, etc., where Ohm's law states that current is directly proportional to the applied voltage. So it is not applicable for the non-linear devices. Then it will not be well and good for non-metallic conductors. Ohm's law not suitable for devices or places where temperature is varying. Where varying temperature devices, in varying temperature devices, we cannot use the Ohm's law, where P power is equal to voltage into current is equal to I square R. It is represented as V square divided by R, where E is also known as voltage V. We can also represent it as V or E. E equal to power into time, where power is represented as V into I into time is equal to I square R into T, where I square R is can be also written as V square divided by R into T. Conditions for applying the Ohm's law. Ohm's law can be applied either to the entire circuit or the part of the circuit. Okay, the Ohm's law can be applied in the entire circuit or one of the part in the circuit. It can be applied to both AC and DC circuits, but we are only studying about the DC circuit in the first unit. Okay, resistors in series and parallel. This diagram shows the n number of resistors connected in a series. Series means the one resistor is connected with another resistor without any connection to the next element. So it is connected in a series or cascade in nature. This formula can be used to find out the resistance or equivalent in the entire circuit, where this figure shows the n resistance connected in series. When the same current passes through one resistor through the another, they are said to be connected in series. But the voltage drop across each of them will vary as per the value of individual resistance. Okay, where each of the voltage drop can be varied, where R1 has some resistance value, R2 has some resistance value. If they are different with each other, the voltage also vary for one another resistors. So the sum of total voltage V equal to V1 plus V2 until Vn. So the voltage across this circuit can be calculated by using addition of all the resistors voltage together. Okay, then resistance in parallel. This circuit shows the resistance is connected to the parallel wise. Here the I is a total current flowing through this circuit and entering to the resistor 1, 2 and 3. The resistor 1 current is I1, resistor 2 current is I2, resistor 3 current is I3, where the voltage supply V is connected to the both terminal. This terminal is connected to in this side and this terminal is connected to this side, where it can be represented as A and B or any other term. The current flowing through this conductor, through this circuit, can be calculated by using I equal to I1 plus I2, the sum of all current flowing through this circuit. where it says the number of the n number of resistors connected in parallel. The both terminals are connected across the same voltage represented here, where but the current will different depending upon the value of individual resonant. As I said before, each resistor may have some different values, so the voltage across those resistors can be varied based on the resistance value, where I equal to V by R. It's an Ohm's law. Ohm's law is V equal to IR, where I can be calculated by using I equal to V by R. Here, how we have to calculate the value of I is V. V is a total voltage flowing through this circuit divided by the sum of all resistance values. So, 1 example 1 divided by R is equal to 1 by R1 plus R2 plus R3. Difference between series and parallel circuit, where the series circuit, the equivalent resistance is the sum of individual resistance. We can calculate the R equivalent. R equivalent means the total resistors across the circuit can be calculated by the sum of all resistors in that circuit, where the parallel circuit means the reciprocal of the equivalent circuit. By reciprocaling this equation, we can get the equation of parallel circuit. That only here says. In series circuit, only one path for the current to flow. Series circuit has only one path for the current to flow through the circuit, where parallel circuit has more than one path. As I shown before, the circuit that has three resistors and the current flows through three directions. Then the current flowing through all the resistance will be same and equal to the total current. In this series circuit, the current flowing through the resistance, through all resistance, is will be same to the equal to the total resistance, where R equivalent is equal to R1 plus R2 plus Rn this phase. Then in parallel, the current flowing through each resistance is equal to total current, where I equal to I1 plus I2 plus In until In. Then in series circuit, the input voltage will be divided across each resistance, where V is equal to I1 plus V1 plus V2 until Vn. Then in parallel circuit, the voltage across each resistance is same, which will be equal to the input voltage. In parallel circuit, the voltage across each resistance, the flowing voltage across each resistance in the circuit will be equal to the input voltage, as like that.